Hey everyone, how are we doing? Kayla, I'm so sorry. Everyone's like, I'm so exhausted. I tried to use the slotted spoon to portion out soup today. They're just like, here's your lunch. And kids are like, lunch? And you're like, oh, whoops. Let's get some real lunch. Let's get some real lunch. What kind of soup was it? I want some soup now. I had some ramen last night. It was good. YouTube all day. Friendly model that I'm in. Queue for BS 475. Yes. Did you see which part were you, Kayla? And then I'll kind of talk because I won't show your homework here. I won't show it directly. So we can kind of talk over some of the questions. Which one were you most wondering about? I saw you mentioned about the Taylor series a day, not like a Taylor series. I've got working, but I don't know if it's doing what he wants. Also, I don't really understand what the code is doing in general. Brain fatigue is not helping. I totally agree. My brain is totally fatigued. Hope you know well that 1A, 1B, and we'll do those. Let's take a look at those 474s. I'm having coding issues for number 3 and 4 on BS 475. So a homemade vegetable soup, that sounds amazing. Which one were you wondering about specifically? Kayla's in the queue first right here, and then we can do Leah's questions, and Cliff's got some questions. And so it looks like Lady Cliff will help out here with some 475. Which one of these were you wondering about most? I've got your assignment pulled up right here. I downloaded it. I sent you a quick message on Discord. You might message me back. There we go. I see your message back. Here we go. So the code is correct, especially 3 and 4. I think yes. Let me take a look. Okay, because I don't want to directly show your work, so that way other people can like work on it. Can we look at 3 and 4? Do you want to just talk in generalities? Let me kind of remove. I've got your assignment open right now, so let me remove it. And let me go to the 475 assignment. 2 seconds right here. Is the code correct? I believe your code is correct. Here, I'll just do a quick check right here so you can let me see. Okay, I'm looking through here. It's a lot to look through. Question number 3, pick your favorite stock, download it. So don't do kill it. You download it. Is it what is this what is the stock ticker? What is this? It says like Chewy right there. What stock ticker is that? So you're looking right here at 2012. Man, did it really do this well? Let's see what it did. Find the mean of the closing stock price for the year. Yep. So find the mean of the closing stock price for this year. Exactly. User model fit the white noise model. You fit the white noise model pretty accurately. The online pet store. Wow. Man. It had a dive at the end of the year. I wish I had bought stock in this last year. Did you know this, Kayla? Did you know that it tripled in price? I'm just going to show this right here. Man, did you know this? I'm not going to show the whole assignment right here, but wow. And this is not the right model to fit. Like, if you're seeing this is not the right model. I know nothing about stocks. Well, if you had bought this stock last year in 2020, you'd have thought 2020 was a great year because you'd be like, I, had $100,000 and now I have $300,000. I'm not saying you should throw $100,000 into a random stock, but I'm guessing that this online stock store kind of blew up. And then we can do some more here, some 3 and 4. I might talk more generalities. I'm just kind of looking over Kayla's right here, and then we'll talk some more generalities here in a moment. But I'm not going to show the code, obviously. This is a good thing for number 3 right here. This is what you want right here, fitting the ARIMA model, which we have in the notes. So this is what you want to get with number 3. So we are talking about number 3 right now. So I'll put this probably tag in the video right here. But this is what you should be achieving. You should see something like this for number 3. This is not the right model to be fitting. Someone's watching this and saying that's not totally right. Yes, because this is not a stationary process. But we are just fitting the white noise model to it. We should be fitting the white noise model to something that is more stationary. Do I have those notes up right now? Here we should be fitting the white noise right here. And you do see in the notes, if you're looking about how to fit the models, go to the notes right here. Kayla, did you go to the notes with fitting the white noise model? So go to the notes right here. It's very, very small. Can I zoom in on that? Over there, you can see it right over there. So check out the notes, has how to fit the white noise model, and you can see a very similar graphic to the one we're currently seeing on the screen right here in the notes. So the notes should have a lot of answers. That's what I'm trying to do as I craft these assignments, is make them like super relevant to the notes on what we're doing. So you can go to the notes in the assignments and you will see code relevant to what we are doing. So this is number 3 we're talking about, especially with plotting the stock. And we just want to get the mean of the year. So that's one of the first questions right there. Think about the mean of the year. So is this making sense, Mubarak and everyone right here in 475? And that we need to go and we need to take the stock, which is at the end of the code right here. So if you're wondering how to get your stocks, you want to go down here to the stocks portion. And we've got the code right here to get the stocks. Probably some of the common mistakes, and we'll talk about the next part of this here, Kayla, in a moment. What is the difference between wrapping autoplot around TS object, around TS, yeah, here I'll talk about that next here. And so when you're grabbing your stock to start, this is all about number 3 right here. And I'll try to answer all Kale's questions too about number 3, and then we'll do number 4 next. When you're grabbing your object, your stock object, you need to give it a start time. Don't mess with your code. You need to give it a start time, and you need to give it an end time. Now, this is where you use the package quantmod to grab. This is a quantmod function where you grab the stock ticker. Could you look over maybe parts? I'll try, Cliff. So I'm not directly checking every little thing. I'm talking in some generalities. I can definitely try to, Cliff. We might do that. We'll do like this, and hopefully this covers it. I'm overworking myself, no doubt. Yeah, I think we all are. We'll give everyone as much grace as we can because, man, I feel it too. I literally dreamt about making slides last night. I'm not joking. I woke up and I was like, why have I been making slides all night? And then I was like, oh, I was just dreaming about making slides. Ha 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 ha. Oh, hee hee ha ha. Oh, hee hee. It's Joker. Not doing it so well today. With this right here, this is just a nice ggplot function, which can make your nice graphics right here to look at multiple stocks. And then this is just the relationships of stocks with positive, negative trends. And then here's an important thing that we should probably be looking at. Once again, we've been stating this a lot. Why do we difference stuff? Like if we take the stock we have right here, let me hop to space. We'll keep talking. I don't want to go too off topic on this. But taking the differences of the stocks right here can get us to almost a stationary process. Why is this process not stationary? I mean, there's a big Q right on here. Dream about it. All the 221 on 3C. I have my graph, just can't get it to do all of 2. Then put your start and end date. Great question right there, Hayden. Set your start and end date to this right here. Redo your start and end date to this, Hayden, so that should help. There's also a window option. You can do like a window, and I think that'll fix it. But I would just change your start and end date. And Kayla's right. There's a jump in the variance. We don't really have a stationary process right here. So we could almost get it. It's just that when you think about the standard deviation windows that you're building, the point of a stationary process is that moving forward from this period of time and forward, we'd have the same mean going forward, and then we'd have the same window for standard deviation. But because of the non-constant variance, we really can't say that this is a stationary process. What does diff do in layman terms again? It goes backwards. So diff is going to take, like if you do diff right here, it's going to take, it uses default lag 1, which is how many periods we're going back. What would the diff, kind of a great job, great question right here. Great job, Brian. What does this do right here? Oh, is it? Yeah, 2020. Sorry, Kale, you are correct. I'd probably give you points. I think I might have said 2021 by accident. 2020 is correct last year, because last year we have a full year to extract. So the diff function is going to take the difference between time intervals, or between objects in a time interval fashion in a series of points. And so the diff is going to return 3. So does that make sense? The diff function right here will return 3. If you change the lag on it, we'll go take a look inside of R right here. So if you go to diff right here, and you put in the vector 1, 4, it returns 3. We can't really do larger differences, but if we go to diff of 2 now, what does this return? What do you see? I don't think and if we predict, yeah, you could predict for the remainder of the year, but you would just predict like using, I don't want to go too off topic. I have a meeting at 3 your time, and then I have another meeting at 3:30 if the person says yes. Ah! It's a good meeting though. So what will this code here return with the diff right here? And then we'll talk more about number 3. We'll probably do some 3 and 4, like do a little 474, 474 back to back. What does this code right here return? You should know what your code's doing. The concatenate is joining this into a vector format. We'll space it out a little bit to the 2 arguments. This is creating the vector 1, 4, 10. And this is the creation of the vector 1, 4, 10. Does that make sense? So this is 1, 4, 10. And then right here, yeah, Connor's in chat right here. Sorry. What up, Connor? Connor, do you have suggestions? We might have a lot of questions about time series here, and Connor can add in his thoughts about white noise and stationary models. So then what is this going to do right here? Yeah, then we'll do that next. We'll do 475, 475, and then Trace will do the 474 right there. You got it, Trace. and then we'll come back. So Hayden will do 4 next here. What is this code going to run? Who knows what this code's going to run? Be careful though. So that would be for diff of 1, and that's a lag 1. And then this right here is a lag of 2. So with this right here with a lag of 2, we're going back 2 periods now. Oh, no worries. This is looking back 2 periods to make the point. So it's asking what is the lag 2 difference? So what is the lag 2 difference here of this vector? We can only find one lag 2 difference because you can't go back 2 periods here. You can't go back 2 periods here. You can go back 2 periods here. So what is the... Oh, we're not on ARIMA models yet. No. We've been fitting the white noise model, so we're not on ARIMA. Connor's like, you're already on ARIMA? We've been mentioning some of the things we need to build to ARIMAs, but we're not to ARIMA models yet. But we are talking about the differences, which is the eye of the ARIMA, which is going to come into an important play here. So Connor already knows when we're talking about the diff right here, we're actually dealing with the eye, the autoregressive, integrated, moving average. And this right here is as we build up our knowledge, we're talking about an ARIMA model. We'll also start dealing with ARMA models, which won't incorporate this difference yet. But differencing is very important, and Connor always feel free to throw in some knowledge that differencing can be used to remove out a trend. So if we see a trend in the data, we can look at, instead of the data with the trend, we could take the data right here, like the Pepsi stock, and we could just take the differences of the Pepsi stock. So the differences of the Pepsi stock is a more stable process, more stationary, but the Pepsi stock does not have stationary yet. It's not a stationary process yet, because we do see these massive shifts in variance, which is sort of the idea of heteroscedasticity. Is this making sense to everybody right here? That when you look at, and I don't know if you've seen the QuantMod package, Connor, but it's absolutely amazing. But the differences in Pepsi right here are more of a stationary process than Pepsi itself. And we made some extra stuff right here, but you can see just looking at the differences, that's what this bottom graph is the differences. And you can see the massive shock at the start of 2021 right there. So we might be able to use the white noise model for this. With better results, we'd use the white noise model on this right here. Exactly. It's really amazing for moving non-stationary trends. Exactly. So with this linear trend right here, we remove it and we go down by differencing it. That's the, gonna meet there. But with the 1, 4, 10, would it be return 2, 8? So with the differencing, and then we'll go through and do a little more number 3. And Caleb, feel free to ask questions because I'm kind of answering without answering. This is just taking the difference of a vector right here. So the diff function right here is just finding the differences at lag 2. So now we will actually get 2 elements. What is the second element of the vector going to be now? What is the second element of the vector going to be? Who knows the second element of the vector? This is a decent test question. Sometimes I like putting coding stuff, sometimes I don't. So what is the second element of the vector return for when we do this right here? It is going to be 7, I believe. And the way this works is it's going to look here at this and go back 2 periods on it to find the difference at 2 periods back. Does that make sense? So now if I were to do this, what is the third element of the vector here? What is the third element of the vector here? So what's the third element of the vector here? So it's looking at this and going back 2 periods. So the second argument here tells it how many periods to go back, and it's going to look at the difference 2 periods backwards. So the element here will now be what? The third element will be 0. Great job, Abigail. Is that making sense? And now the next element should be -1 right there, because it's just going back 2 periods. So it's going back 2 periods and finding the difference between those 2 periods. If you change it to this will change how it works, and it'll just go back 1 period. So now we should get 3, 6, 1, 0. No, 3, 6, 1, -1, 0. 3, 6, 1, -1, 0. Yep. Just always work with these codes, look at them, see what they're doing. We'll continue through here. I'm gonna hop back to space a little bit. This is Kayla right here, more direct, like not direct answers, but trying to make sure like, hey, you're doing this correctly. More on number 3 here. Let's just put on a little chill music. Connor, feel free to offer your advice. Connor, you know stuff really well. I think that, do you notice any patterns about your predictions and your answers from 3B? Yeah. Yeah. And so, yeah. This is, so Kayla, so what is the, so what the ARIMA thing is doing, what the ARIMA function is doing is it's setting parameters. You're basically saying, what will I use? So let me actually, so let's talk just a tiny bit of what is ARIMA doing. This goes a little bit above what we're doing now because we're seeing how to use the ARIMA to set the white noise. Let me go grab setting the white noise from here. So let me show you how to set the white noise, which is important to this assignment. And then we will talk just about, make sure we have this right now. Let's talk about how to set the white noise. I'll show you where it's at. And then let's talk about what this is doing, kind of a little more detail than where we're at, which might help with the understanding. So let's hop in here and do this right here. How to set the white noise model. Let's go back. So once again, the slides have the notes, and this right here has how to set the white noise model. So let's go grab it. You know, let's go grab our own random stock. So we're going to go and take right here. This is the Nestle data, for those who have had Sievers class. But we're going to grab a stock instead. I can access Mara now? Oh, no. Yeah. So the white noise model is really just taking the mean and moving forward. And at times we shouldn't apply that. I'm just going to grab some end start date right here to help myself out. Once again, gotta love copy paste code because it can super help. Let's go look at 2010. Was 2010 a good year? Stocks are just crazy these days. The stock that Chewy stock just went absolutely nuts. And let's go grab the get stock. Okay. Let's drop it in here. Let's look at Pepsi over the course of 2010. And let's take a look and talk about what's going on right here. Okay, so where's our start end? Here's our start end. Store those as dates. Let's go grab the Pepsi stock from the start to end. This should create the Pepsi thing. Oh, wait. Oh, we got it. Did we create it? I lost my mind. Okay, good. We've got the quant mod package up. Make sure you're running quant mod. Library quant mod is required for these. If it says it can't find the function, library quant mod. No auto ARIMA. I know, right? We should show them that. Makes life a little bit too easy. And this kind of goes to the question that we have to start this. Like, what's the deal with this ARIMA right here? So as we were talking about ARIMA previously, and I'm going to grab the notes. Where did I put that? As we were talking about what ARIMA is, ARIMA stands for Autoregressive Integrated Moving Average. And these are different components. And if you want, I've got the notes. I've already got the notes ready for autoregressive models. So here's the notes on autoregressive models, talking about how they work. And we're going to show a lot of examples and go through how autoregressive models work and know when to pull the autoregressive model and when not. Invest in GE stocks. So we're going to go through and talk about the autoregressive models, and there'll be a lot to talk about here with analyzing them, looking at them graphically, and going through different data sets. So what we are trying to find is a parameter, and maybe it'll help to see this. At this point, we're not doing autoregressive models, but the parameter we're looking for is this phi right here. So this is the parameter we're looking for. Does this make sense, Kayla? This is a little more in depth than this assignment goes, because all we're doing is setting the white noise right now, and it has a certain ARIMA parameter set. But this is the phi right here for the parameter for what we're using if we are setting an autoregressive model. And it's kind of a weight to how much we're autoregressing. But we can autoregress on more than the first order. We can, well, this is showing right here. Here's the autoregressive on more than the first order. But now look, if we autoregress on more than the first order, what do we have? So if we autoregress on more than the first order, what do we have? So now we're going back another time period. We're saying somehow this model is going to use previous time periods, and then we have a weight to the previous time period, how much it's correlated with it. But now we have two parameters. Is this making sense? We have two values that we need to use to make this prediction of the value. Once again, this is going beyond what we've done right now. We'll be going through this next week more sequentially and talking about these equations right here and how we use them and going back certain periods with this. So that makes sense, right? So if you were to do this, you could go in here and fit, and we should be able to fit the ARIMA, and we should be able to set the autoregressive to, we should be doing it. Should be fine. I wouldn't do this by myself. This is not going to work. Oh, it's mad right here. Error. Let's still look at the ARIMA fit. It's getting mad at me. Oh, wait, did I put it in the wrong spot? Oh, we might not have Y. Do I have a time series saved right now? Unused argument. I think it's estimating the parameter on its own, so we'll just let it estimate its parameter. Did I have a time series saved as y? I don't even know if I have a time series saved right now. I do not, so I don't know what it used. Do I have any time series stored? Let's go grab the Pepsi, which should be fine as a time series. Let's go look at the close. We're fine. Okay, it fit. Okay, so right now it's using the autoregressive 1. We haven't done this yet, but it's going to make an autoregressive 1 model. So now, if we were to take and plot this, here's the model we get using this autoregressive 1. I'll kind of talk about what Connor's talking about here in a second with the AutoArima. Makes things a little bit too easy. It's something we will be using, and you'll just be like, oh, life is so much easier now. But this is our model here. But this is not the white noise model, which I know we shouldn't be fitting the white noise model, but let's fit the white noise model. Take a look at how this changes when we don't add any parameters. We're not going to use the autoregressive. We're not going to use the integrated. We're not going to use the moving average component. That's what these are, the autoregressive, integrated, moving average components. Does that make sense here? As we look at these equations, we're going to try to figure out the values that these should be. We're trying to figure out this value. Oh yeah, we could get some overfitting issues, and that's what we'll talk about training and holdout, even in 475. Lots of topics, like how do we know if our model's good? We have to test it on new data. So these are the values you're fitting right here, and this AR right here is the value of how many watts you have. This goes a little bit beyond what we've done, but this value of AR is the value of how many watts we are using. So the value of AR is the value of how many watts we will use when we build our equation to make predictions. The value of AR is the value of how many, and Connor's right there. Basically, Connor's exactly right. It's how many times we're using the lag, which incorporates this right here. This would be with 2 lags right here, exactly what the notes state, and it's the weight. They will be assigned value. It's how many different weights we are using. So the weight to the lag of the previous point. So this would be just a lag 2 right here. So if we go right in here, and it should, I think it automatically finds and optimizes based on AIC. We should find right here, here's fit with lag 2, and you can see the model changes. We really didn't get any shift. This is ridiculous. It let me do it, so I did it anyways. We're not going to do that right now, though. We're going to use the white noise model because that's where we're at. So this is not saying, so it's Connor's point, he's like, you're already on ARIMA models? No. We're just using this to make this. And there's actually a way to fit the random walk, white noise models and stuff like that, not using the ARIMA. But really, I find that right now introducing the ARIMA code is going to show you for later on, because it's going to start like being like, oh, we can just always use the ARIMA right here to fit our model. But if you want, the ARIMA has no parameters. Think about this. We're not using an autoregressive model right now. So what is the parameter for the autoregressive coefficient for this model, or the weights of the autoregressives right now? Or how many autoregressives, I should say. Using the previous observation is an additive increment or multiplication more effective. Might be. And so how are we using autoregressive right now? Like, because we're like a week into the course. How are we using autoregressive right now? How are we using the autoregressive component of this? How are we using the autoregressive component of this? The answer is, how are we using the autoregressive component? How many estimates of phi's are we making right now? How many estimates of phi's? And these are notes for next week. How many estimates of phi are we making right now? Have close in the forecast fit. Oh, then I'll answer ONS. And so, does this make sense here, Kayla? How many estimates of phi are we making right now for the autoregressive part? 0. We're just not doing it. We're not doing it. So you might say, well, Brian, we haven't done autoregressive. You're right. The answer is, we're not doing it. How many are we doing for the integrated right now? The integrated. So how many are we doing for the integrated? How many estimates are we making for the integrated, which would be the differences right here, which we've talked about differences a little bit. We've seen we can difference to remove a trend, which might be important. How many estimates are we making for the integrated? 0, we're not using it. How many estimates are we making for the moving average? So we actually talked about moving average in 474 today, towards the end, doing a moving average. We're making no estimates. No estimates. And we'll talk about how the AR is going to be a long-term memory, And the moving average is going to be short-term memory because it's going to have a window that moves across and kind of forgets as the window goes across. And the moving average is going to have estimates for how big of the window we need to make. So Connor pointed out an amazing thing right here. And I think, let me do Kale's question first, then we'll do Connor's. What is the difference between, and let me grab those right here real quick. Autoplot, yes. So we're going to talk about Kale's question, and this will kind of wrap up number 3, and we'll try to do number 4. Sorry, I'm on a deadline today. And then we need to do some 475. Right here, Autoplot, Pepsi close. This will not get you the forecast right here, and it looks like I'm missing a parentheses. There we go. So Autoplot, Pepsi close is not bad. The only thing we get right here, so it's smart enough to know, could you do, yeah, and Leia's question, we'll do that here next. Is this making sense here, Kayla? Kayla, everything it looks like you've done is correct. You just want to be able to get, and I did a different year, so you can't directly, no one's directly copying. For the question, do we need to use the diff function or just want to interpret the results as is? I don't think I asked you to use the diff function on this, but you could, if the question asks, I'm trying to remember what I asked, you could go over here and take the differences and run this on this. Let's go ahead and fit a model here. And we've got the fit now. And now, does this look like a better model? I don't think I said to run on the differences, but how does this look? You've got some interesting variation here. Wonder what that was. But this, and in truth, this looks like a way better model right here. This looks to be, you know, you got your 68, 95, 99.7. What does this look like? It looks like a stationary model to me. And now we just fit a model on the differences. And so looks like that is a way better model. It's having a little bit of fun for a second here. Looks like model's doing way better. So does this make sense right here as we look through this and we look at the differences right here? So how is fitting it to the white noise? It isn't changing except for adding the purple bar before you. Yeah, this difference right here. The fit is giving you the what? What is the fit giving you? I've applied a different fit. The fit right here is giving you a what? And I'll show you one last argument right here. Are we inside the forecast? To answer Kayla's question. The fit is allowing you to get a what? I'm inside the wrong thing. The fit is allowing you to get a what? So this is the difference right here, that this allows for what? And this just plots model. Using the fit allows you to get a what? Here's the future. So using the fit allows for a forecast. Does that make sense right here? So that's, does that directly answer your question, Kayla, right there? Like what's the difference between the two right there? If we have the fit, we can use the model to make the predictions so we can actually make a forecast going forward into the future. So that's the good thing about using the fit right there. If we forecast on the fit, it has the original values, and then it's able to use the equations from the fit. And the equation from the fit is going to give us the parameter estimates for the model so that you could see here your phi's or your other parameter estimates that are used as equations, because these are the equations. This is not the equation we're using right now, but the model has parameters that will make predictions for y. So that is stored inside of the fit. And we mentioned this earlier. This is just like running right here, summary of M right here. I thought it was fitting to white noise. No, it's fitting the white noise to our model. So the white noise model is just going to use the mean and constant variance. So this is the white noise model right here because we're just using the mean and constant variance going forward into the future. This is a ridiculous model to fit at this point. One, because we don't have a stationary process, so we wouldn't want to use this because it's like this model is drastically changing over time. There's some sort of seasonal effect right here, or it could have a linear trend. Hence why if we difference this, we might get a much better model. Is this making sense, Kayla, here theoretically? Like, you should know when you do things wrong. Part of doing statistics is doing things wrong and then knowing what the issue is. And this right here would be not a proper fit model. Like, it's a bit ridiculous to think Pepsi would have a sudden jump downward. We talked about another model today. I don't want to go. I remember I've got 29 minutes. But is this making more sense right here? And then I think we need to talk a little on question 4. Oh, Connor put a big thing in the window right here. TC, train control. Oh, man, Connor's thrown in here some carrot. Yep, we definitely, I'll look at that here in a little bit. I don't have enough time today. Connor, that is awesome. Connor dropping some awesome carrot stuff right here. Train is from the carrot package, and we will be doing, wow. Connor just, great job, Connor. For the prediction portion, we have the white noise model. That is correct. Because we're just on our easiest of models. It looks like you've done everything correct, Kayla. So if you're achieving stuff like this right here, right now, basically all we're trying to do is forecast. All we're trying to do is just use models right now to forecast. Is this making sense? I'm hopefully giving people a little... Is this a good ah? Or is it like an ah like ah? Or is it like an ah like ah? So where if we're in person, it's much easier to be like... Everything looks accurate right now from what I'm seeing. And if you look at how this is making predictions, and this kind of alludes to 3 and 4 right here, the white noise model is making predictions because the intercept of the white noise model, which is this right here, is just the what of the data. I'll kind of show some other stuff for number 3, and then I might hop to 474 real quick. The intercept of this model, which is what you're meant to see, is just that right there. Does that make sense? Look at the model right here. Here's the intercept, here's the across, and here's the value of the intercept. Yeah, that's it. That's it. I think there's the aha moment I was hoping for. And then the standard deviation of this model is this. Now, where do you see this in this output? What is 2 times 2? Anyone know what 2 times 2 is? 2 times 2 is basically 4. And we're getting weirdness on this. I always hate this, that I think just the way it's estimating it or the decimals that are carried behind this, we should be seeing nearly identical. See, you can do a no intercept ARIMA. Oh, man. Yeah. We should talk more on this, Connor, like on what Seaver showed and everything. So, like, I've been looking through Seaver's notes. And as you know, Seaver does everything by hand. So you have to copy everything down that Seaver does. So right here, you can see what we have right here with the ARIMA model. So this is just right here, a basic model. We don't have to have the intercept. We can remove that. And that would just be removing model hierarchy to go to some 320 terms. So which one were we doing next? NCSS. Yeah, that's what. What do you think, Connor, about us using R over N? Sorry, I'm not trying to. I don't know what to talk about. I think you love R. I know you love R. You say, no, Brian, bring back NCSS. Oh, did I miss the... Let me grab the last bit of Connor's code right here, because I want to go through and look at Connor's code. Thank you so much for posting this here, Connor. I will be taking a look at this. Creating a model right here. Do I have this data set? Which data set are you using, Connor? And then let's do another question. Preproc. Oh man, that is some awesome code right here. And I know you've sent me some other code too. Okay, which question are we gonna do next? Which one was next? I think we should hop to a little 474 just in case, because I am on a time limit today. I have 2 meetings. And I think it was Leah's questions are next. Could you go over 1A and 1B in 474? So let's go look at 474, 1A and 1B. And I think Trace had questions too. Thank you everybody so much. Today is one of those busier days. Let's go take a look at the assignments. Here we are, 474. And you know what I might do? With the loops assignment, I'm doing something. I just sent out an announcement saying since we just started loops today, I'm extending it till Saturday night. And we should be good on that. I'm going to move the dates a tiny bit on this. 2 seconds. I'm moving dates. It is hard to plan things out in the future in the summer. 1 day is a magnitude of time. Thank you to everyone who started early on this. Someone's like, oh no, well, if you did it, you did it. That's good. I'm moving dates just slightly. Busy week next week. There we go. I also moved the next assignment. So I sent out an announcement. There we go. Number 4, let me look at it really quickly. I think I can help with it. Okay, awesome. Let me take a look at number 4 real quick, Kayla. 2 seconds right here, then we'll hop into the other one. Thank you so much, everybody. Still gonna do it right now? That's the best thing ever. You want to do it right now? Let's go take a look. Thank you, Kayla, for all the help you're giving everybody. I'm going to take a look at number 4 real quick. Let me look through here and I'll tell you if you've done everything correctly. I don't want to show answers, so 2 seconds here, everybody. Okay. Create and plot the white noise model. Make sure the chunk with your seed to have constant results. So, are you running? Did you remove out the seed portion? Convert walk. You might have done. Okay, wait. What happened here? Oh, I think I see an issue, Kayla. I think you've made more work. I think you might have made more work for yourself. Let me see right here. Just want to drop it. Hey, Mary, good to see you here. Excellent job. Good to see everybody. Let me pull up 474 assignment. I'll show you the intent of it. 2 seconds. Okay. 475. Losing my mind. All right, 1 moment here, everybody. Okay, I'm pulling up the assignment. Okay. And here we go right here. Okay. Yeah, I think I see the issue. Okay. Yeah, I see the issue. Let's talk about this right here. And then we'll do 474. Okay. I'm sorry, Connor. I had to cut the hair. I'm sorry. Here, let's check this out real quick. You ready? So, to create the white noise model, make sure to run a chunk with your seed to have consistent results. So this right here, it's going to make a random walk generation right here. So what you want to do is you want to put in your random seed right here. And then don't put in 999. That's my numbers. And then create and plot the white noise model. So on top of this data right here. So this is, maybe I wasn't specific enough on this, but you want to take this data right here that we've just created and plot the white noise model on top of it. So we need to add in a chunk right here. And let's go here and just call this white noise plot or white noise creation / plot. Yeah, you gotta watch out with those slashes. They'll sometimes mess with that code. And so now we want to go here. We got our object, we got our walk. And with this, we can see the walk. It might be over there too. And create and plot the white noise model. So we want to do the ARIMA fit right here. And with our ARIMA model, we're going to throw it onto the walk. And then we're going to do order equals, or it's in the notes, 000. And there we are is our model. And we'll store this into fit right here. And now that we fit this, we can go to auto plot of it. How do I always forget that O? And that's not it. My brain broke. What's it mad about? Let's go here to auto plot of our walk. Oh, you know why? Sigh. Okay. And you know what's easier? Walk, save into time series walk. There we go. Now let's fix this. Now let's take a look at this. There we go. And yeah, exactly, Kayla. You caught it as I caught it. You caught it as I caught it. It's that. Really? Really? What am I doing wrong here, everybody? Forecast around it. There we go. Small mistake, sorry. Need that coffee. Last sip. Throw the forecast around it. Now it's working. And there we go right there. There's the forecast right there. So a little bit of number 4 right there. Easy to make mistakes. And just like, why is the code not working? Why are we not getting that forecast? And this is the intent for number 4. Does that make sense? So you can use the ARIMA sim. The ARIMA sim can simulate a white noise for you, but we're meant to use this up here with the generation of numbers because down here, graph the differences, and then to identify the parameter of the random walk. So you are using your random walk. Just want to make that clear right here. You are using your random walk, and I'll just do this one to help out a little bit here. And then let's head and do some 474. I need to do some 474. Okay, so difference graph. So when you graph the differences right here, you want to look at your differences of your random walk right here, and you can see the differences. I'm not going to tell you what the parameters are. That's, yeah, so I should accept. Please tell me if you ever think the graders mean. You're more than welcome to look at your grades and be like, I think I got too many points taken off right here. But all we're doing right here is basically taking the same sort of code and looking at this. How do I always forget that? And we can look at the differences in the random walk, and maybe, just maybe, we should see some stuff right here of note. We should see some stuff up here to note. Now, the other parameters might be hard to tell, but if you look at the differences of the random walk, then you should see some of the concepts we're talking about right here. Really? Interesting. And so we should see some of the concepts we're talking about right here. With all this, is this making sense? Or we're looking at we're not looking at the differences. Oh my gosh. Brian, slow down, man. We are. We're looking at this. Oh my gosh. There we go, the standard deviation. Do we need to add lag arguments to that? The differences will do the lag. We won't do a lag argument. Great question, Olivia, right there. We won't look at the lag on it quite yet. Well, I mean, we are looking at the lag. It's just a lag 1. So within the difference argument, it is just doing a lag 1 by default, and kind of understanding what's going on right here with this auto plot and understanding the parameters of the random walk model, which if you take a look at this right here, this last little hint, and let's do 474. If you take a look at that right there, sigma squared, there's the fit of the model, and I'm doing the differences right now. There's just some things to notice right here with certain values, and the parameters of these models are very important to understand that the standard deviation is the parameter of the white noise model. So the white noise model has a mean of 0, usually constantly, and we have the standard deviation is the parameter of the model, like the variation within the white noise. Does that make sense right here? Let's hop back and do some 474. But the parameter of the white noise is the variation of the white noise. And you can see right here, this has more variation than our usual variation of 0. And you can kind of tell how this is being generated if we go back here and look at the generation of the white noise model and how it's being created. Let's head back here to space. Okay, let's see. We got enough time, at least for one of those 474 questions. I'll probably be doing some office hours tomorrow. I think I will. Let's go here to 474. And let's take a look. Sorry, buddy. Gotta hop to meetings after this. And let's take a look. Okay. Here we go to 474. Let's do it. So for the first one right here, what is the first thing we should identify in 474 right here? When we do loops, what is the very first thing to identify? I think I should. Probably do like an hour tomorrow or something. What is the first thing we should identify? And this is very similar to what we did in class today. Let's bring up the class notes. So here's our class notes from class today. And if you look, very similar to this. Remember what we did. So we need to understand what we are looping through. I don't want to quite give you the answer for this. I want you to think through it. So what is the vector we're going through? Spooky bones. Oh, yeah, no, exactly. Actually, that's what I was looking for, Connor. Connor knows what I'm talking about here. Connor knows what I'm talking about. That's what I usually identify first. What do I usually identify first? Connor's right about those spooky bones. The first thing we're going to go for... When I did this in class, I did not get x1 equals x. And there, these notes are posted, so this is going to be a huge help right here. So what's the first thing we identify? Connor's giving a huge hint. Usually I identify first the what. And the answer is the code that repeats, which will become our what. So we usually want to identify the what, the code that repeats, that becomes our what. So what is this? This is the, Connor said spooky bones. What's Connor mean by spooky bones? The what? It's my big hint right here. Not shoulders. I mean, it is a shoulder, but that's part of it. It's everywhere. Skeleton. Great job right there. Let's throw some 20 points. We're throwing a bunch of points today. What are we doing not giving out points? Go 50. The skeleton. The skeleton is what we want to identify. So we need to take this skeleton and change it so that we can loop through it. Now, what are you going to do first? When Brian wrote his loop today, did he start by writing for and then writing his loop? No. I started with the first instance of the loop and then made it so, and let's rewind time right here. Let's rewind time on this one and do the example from class again, because this is basically this question. If you notice right here, we have here that x equals to 3. Now, we have not figured out what I is right now. But first off, what I'm going to do is I'm going to find my what. Now that I have a skeleton, a thing that will repeat, I'm going to find my what holder. What will I find that will replace these values that I can change when I run my loop with my control panel for the loop? So what will I find now? And make sure your code runs. Just take your code and be like, that runs. So like make sure it runs. That's an answer for the classroom assignment. The placeholder. So let's go ahead, and if this becomes a placeholder, let's just call it I. It can be called anything. But now that that's called I, what would 1 become? And notice the structure. It's not always going to be like, I could change this so it could be like 1.5. That wouldn't work, but you have to watch what you have right here. Like this could be, here we're changing the code right now, so watch out. I've changed the question. This makes it a little bit more difficult. Okay, this is a different version of the question now from what we did in class. So this here is I. So what is this right here always? When you look at the structure of this, the next one is going to be what? Like instead of 1, like this is now I. So let's say I is 2 to start. I is 2. Does this still run? Hey, it still runs. Does that make sense right here that I have code that still runs when I do this? And this will be I minus 1. Now, once again, code in those little bits. Don't try to do it all at one time. Does this work? Okay, we're good. It still works. Does everyone see we're just making sure it works? Smaller, the better. We haven't broken our code yet. We could also check up here to make sure our vector x is not changing because we haven't really done anything crazy to it yet. But here's the confusing one. I changed this from class. What is this now? This is different from the class example. What is this now? Be careful. It's not I minus 1. Look at the structure by which it changes, and there's a repetitive pattern to it related to one of the numbers, the placeholder number. So this is no longer I minus 1, which it was in class, but we've changed the structure of it now. So it's a slightly different example. And once again, don't write the whole for loop. Someone's writing the whole for loop right now. Just this little bit right here. What is the structure of this one right here? It's no longer I minus 1. Close. It's not I minus 2. Because if you do 2 minus 2, that won't be this right here. 3 minus 2, I divided by 1/2. Exactly. So I like to put things inside of that. We're just going to take 1/2 of what the I value is. So whatever I is, which is the first number right here, it'll be 1/2. Great job, Lauren, right there. I divided by 1/2. Great job, Connor, also. And so now it's still running and we're getting 4. So now what we want to do is we just want to see if this loop works. We're going to manually run the loop, like when you're just cranking ice cream by yourself and you're going right here and you're just changing the values. And we got so much stuff in the global environment. Let's remove all that. We're just going to manually run this loop. I ran it on the second instance. Now it's running. And does everyone see I'm getting a longer vector right here? Look at the vector up here, and you will see that I'm increasing what I is, and it's running the loop for me. But I don't want to do this. I want it to do it for me. Now we have to remember, use the snippets, quickest way to code. We go here and we put inside of here our variable placeholder. This is the thing that will change when the loop runs. I was changing I. I want the loop to change that for me. Now I look, the loop will start at 2, and the loop will go through 100. 2 through 100. All this is doing this work right here for me, starting at 2, going through 100. You might say, well, why don't you start at 1? If we started at 1, the loop would plug into here 1. Well, that works. But then it would plug in 1 minus 1, which is 0. And there is no 0th element. So we can't do that. We're not going to start there. We're going to start on the second element and store into the second element. And so we have it. And guess what? We don't need to manually do this anymore. The loop does it for us. Loop, you want to do it? Uh-oh. What'd I do wrong? For I in... Oh, my. How'd I do that? Bad copy. There we go. Forgot my parentheses. Didn't close my, what did I not close? The something. So the loop was like, and it wanted that closure on it. So there wasn't a closure on the parentheses. I was like, what did I do? What'd I do? Is this making sense right here? And who's doing a little bit better on number 1 right now? We'll try to do one more here from 474. Sorry for the, I know we did a lot 475 to start. Can we look at it? Yeah, let's look at 1B right here. So that is 1A. Let's take a look at 1B right here. What is 1B? Going down here to 1B, the following loop goes through the words, today is a nice day. It then finds the number of characters in each words. So when you think about what a for loop is doing right here, like if we unwind this for loop right here, every time you're in this control panel right here, yeah, Connor, send me a thing on Discord. Just bloop me on Discord and I'll send it right to you. You can give me your thoughts. And if you want to ever help with any of this, which you already have, you're always welcome to. And you just, I really appreciate it. I really like, yeah. And once again, I don't know. You've got me Red Bull and stuff before, and I really appreciate it. So I should get you some Red Bull. What is this line of code doing? This basically gives away the answer if I explain this portion right here. What is this line of code doing right here? Trace gets it. Trace got it right there. You got it. So Trace is saying when this runs right here, it stores into the object word the character string today. And then what is the next line of code doing? After this code, so Trace, you can kind of put the next answer here, which almost literally gives away the question. What does the loop do when it goes inside the for loop now? Like now, let's say the first time it runs, it stores today into Word. So it's going to store, and here I can show right here what this loop is doing. This loop right here, when it runs, is going to start right here by going right here and storing I2 into I. Does that make sense? The first time this runs, it stores 2 into I. Then the important question is, what does this do next, though? After it stores today into Word, what does it do next? And this is where the mistake happens, and we talked about this in class. A lot of people then don't realize, no. Remember what Word is. So what does it do next here? What does the code do next? After it stores today into Word, it's going to enter into the loop, and what's it going to run? The answer is, it just runs the skeleton. A lot of people like to substitute in and say, well, it's gonna do this right here. But no, that doesn't change. The skeleton doesn't change. It is running this because Word is today. So it's not doing that. Stores the number. So it's going to do that of what Word is, right? But Word is this. So it is doing that like interpreting what the code is doing. To get the parameters of the ARIMA, do you just use standard? That is, yep. That'll give us the parameter of the white noise, not of the full ARIMA. Not every ARIMA is going to have a parameter that's the standard deviation, but the white noise, which is the model we fit. So for that specific ARIMA model, Hayden, great question. For that specific ARIMA model, the parameter of the ARIMA model would be the standard deviation. That is correct, or the variance of the model. So that is correct for that model, not for all ARIMA models. Later ARIMA models will have more parameters than just the variance. So what it runs next is it just runs this. Does that make sense right here? Does this make sense? Like this loop right here. Great job, Hayden. So this loop right here is storing 2 into I, running the inner portion of it. Then what will this do next when it loops back up? Like, what is the code doing in the background, which Brian was doing by hand? What is the next thing my loop on this screen, which is pretty much the answer to the question we're working on? What does it do next for the next thing on the screen? What is it going to do next right here? What does my loop do next when it goes back up to the top, because the loop's back up here now? What does the loop do next? We got just a minute or two more. I got a meeting directly at 3. It is iterating. Yep. And then, yep, exactly. Connor's right. It's iterating, and it's just going back through and iteratively going through and doing this, doing that, and then ... and then store into 100. Does that make sense theoretically here? Who feels like they understand 1B a little bit more? Because we're trying to understand like what the loop is doing, because if we can see what the loop is doing, we're like, oh, it's storing into I2, and then it's running the skeleton. The skeleton doesn't change. The skeleton is always the same code. It's always running this same inner code. So that's why our inner code has to be exact, because it's just going to change what the placeholder is. You don't just think about what it's running. I don't want to quite say the answer, but, and then are you asking about why? Is there a Y on the screen? Is something being stored into Y? What is the only thing having something stored into right here? What is the only thing having something stored into right here? So I don't want to put the full answer on the screen, but the theory behind this is the exact same as what we're doing right here. Sorry, I keep thinking it's on the other page. How when we start this loop, 2 is stored into I, and then the loop is run. Then 3 is stored into I, and then the loop is run. And then 4 would be stored into I, and then the loop is run. And technically, we would need before this the vector x creation or an initial value of x. But is this making sense right here? Yeah, there we go. I think so. So we don't need to store anything. Let me throw 20 points. Trace, great answer right there. We don't need to store anything, but that is what is being stored into it. What is being stored into it is the number of characters. So if you look at what the loop does, and so go ahead and try to grab the loop and take the loop and run it and see what you get. Oh, I didn't create Y. And if you run the loop, you see the number of characters are being stored in it. And then what you want to do is you want to try to write your 10 lines of code, and you'll know you have the right 10 lines of code if it creates this same thing. So I'll probably have to end on that. But does that make sense? Like, put your 10 lines of code, which probably shouldn't put it there. If you were to take your 10 lines of code, which are literally right here, there we go. If you take your 10 lines of code, if you run and get the same result as below, right here, you are right. Now be careful though. Once again, I want to point out this last mistake right here. The skeleton does not change. Zaid and Trace, great job. I'm gonna head off. I have a meeting directly at 3, then another meeting right after. We'll do office hours tomorrow. I will see everybody later. Until then, bye for now, everybody. Bye for now. Sorry for the short office hours. We'll be back. Why do I scream all the time? I don't know. Bye for now, everyone. Be back later. Connor, mess with me. I'll send you the assignment.